Are you struggling with mathematics? Do you hate mathematics? Are you afraid of mathematics? This is the teacher who can help you love mathematics. I can break down difficult topics into something easier and understandable. Now, this series is Steve Cohn's Ultimate Revision Guide. Now, let's see, differentiate the following with respect to x. We know that if you have y equal to ax to the power n, and we differentiate, here are dy dx, this is the same as anx n minus 1. The n has to come down and multiply the a, xn minus 1. And this is the same, you can see that this is the same as an xn minus 1. Why? Multiplication is commutative. So n times a is the same as a times n. And also if you have, let's say, y equal to a xn plus b xm, if it is a polynomial, then dy dx is equal to an xn minus 1. The a is multiplying the n, then plus bm or mb xm minus 1. The b is multiplying the m. Now let's consider the examples given to us. Now the first one, we have y equal to x to the power 6 minus x to the power 3. And when we differentiate this, our dy dx, this is basically the 6 has to come down. So we have 6x6 minus 1 and then minus 3x3 minus 1. So the n is 6 and then our m is 3. And clearly this is the same as 6x6 minus 1, 5 minus 3x squared. 3 minus 1, that is 2. Now let's see the second one. We have y to be equal to 3 over x plus 2 over x to the power 5. Now we know from indices, if we have a, that is a to the power negative n, this is 1 over an. From indices, we have a to the power negative is 1 over an. So when this goes up, we get the negative. But this x to the power, so when it goes up, it's going to be 3x minus 1. This is not in standard form, so we have to make sure it's in standard form. And when you write it like this, then it is in standard form. Similarly, this has to go up. So you have 2x to the power negative 5. From this principle, a to the power negative n is 1 over an. Now, when you differentiate dy dx, now our n has to come down. So that's negative 1 coming down times 3x negative 1 minus 1. The rule says subtract 1 from it. Let the n come down. So we have negative 5 multiplying 2x negative 5 minus 1. And clearly this is giving us negative 3 x to the power negative 2. Negative 5 times 2, that's negative 10 x to the power negative 6. And applying this principle, a to the power negative n is over a. And this, we can leave it like this, or it is still the same as negative 3 over x squared minus 10 over x to the power 6. Now let's see the third question. The third question, y to be equal to x to the power 7 minus square root of x to the power 3. Now from indices, this is the same as, you see, we have x to the power 7 minus x to the power 3 all to the power 1 over 2. And we know that if you have a to the power n, all to the power n is a m n. from indices, we know this. The m is multiplying the n. So 3 times 1 over 2, that is, so this is the same as x to the power 7 minus x to the power 3 over 2. That is our y. And when you differentiate, the y, the x, this is equal to 7x, 7 minus 1 here. The 3 has to come down, so minus 3 over 2 coming down, x, 3 over 2 minus 1. And clearly, this is 7x to the power 6 minus 3 over 2x. Now, this can be 2 over 3 minus 1 over 2, so we have 1 out of 2. So that is our dy dx. Very, very easy, very, very trivial. I would urge you, pause the video, try the questions on your own. Now, on the main lesson, all the lessons that is in the WASI syllabus from Form 1 to Form 3, everything is available on a pen drive for sale. I've taken my time. The lessons have been arranged according to the content of the syllabus. This is just a revision guide. I would urge you to get the main video. Everything, all the challenging questions, everything have been solved. A lot of it, I have the weak students in mind, so I've taken my time and then I have done a wonderful work. Something that would whet your appetite. Now, let's see the fourth question. The fourth question, we have y equal to 2x cubed plus 5 over x. And this is the same as 2x cubed over x plus 5 over x. Why this? Because we know that if you have a plus b over c, this is a over c plus b over c. So that is what we've done. Now we know from indices, when the bases are the same and you are dividing, you subtract the exponent. X to the power 3, x to the power 1. So this is the same as 2x squared plus 5x to the power -1. And this is our y. Now when you differentiate our dy dx, in this case our 2 is coming down, so we have 4x to the power 1, because 2 minus 1 is 1. 2 will come and multiply 2, which is 4. And then this we have -5x -2. Why -2? Why -2? Because -1 minus 1 giving us -2. We can either decide to leave our answer in this way, or we can put it as 4x minus 5 over a squared. We can leave our answer in this form as well. Now let's consider this example. I'd urge you to pause the video and try the question on your own. No pain, no gain. Mathematics is not a spectator of sport. Now, mathematics is very, very interesting. For you to enjoy mathematics, you have to work hard. It requires hard working and self-discipline as well. Hard working and self-discipline. Now, if you want to enjoy mathematics, I would urge you, get my videos, get my lessons. I've done the wonderful work. I have done all the lessons in the WASI syllabus from Form 1 to Form 3. Everything is available on a pen drive for sale. I have taken my time. I've explained everything, all the content in the syllabus. I've arranged it according to the content of the syllabus. Everything, especially the challenging questions, I have all of them, and then I have solved everything, taking my time, because I have the weak students in mind. Now, differentiate the following with respect to x, and the first one, we have y to be equal to square root of x plus the cube root of x. And clearly, this is the same as x to the power 1 over 2 plus x to the power 1 over 3. And when we differentiate this, dy dx, the n has to come down. So n coming down, you have x and minus 1. Then plus 1 over 3 coming down, x 1 over 3 minus 1. And clearly this is giving us half x to the power -half. That's half minus 1, that's -half. plus 1 over 3x. Now, that's 3 over 3, so negative 2 over 3. Negative 2 over 3. You can decide to leave our answer this way, or it can come down. Now, let's leave it this way. Let's leave it this way. But we have the second one, y to be equal to 7 over x to the power 4 minus 6 over cube root of x. Now, from here, we can write this as 7x to the power negative 4 minus 6 x to the power negative 1 over 3. Why? If you have a to the power negative n is 1 over a n. From here, when you differentiate dy dx, at the end you pause the video and try the question on your own. Negative 4 comes here. Negative 4 times 7x, negative 4 minus 1, and here the negative 1 over 3 will come down to negative. Negative 1 over 3 times 6x, negative 1 over 3 minus 1. And clearly, negative 4 times 7, that's negative 28x to the power negative 5. Negative times negative positive. 3 brings up 1, 3 brings 6, 2, so we have 2x. Negative 1 over 3 minus 1, that's negative 4 over 3. Negative 4 over 3. And this is the same as negative 28 over, you have x to the power 5 plus 2 over x to the power 4 over 3. Now let's see the third question. Let's see the third question we have. Y equals 8. We have the fourth root. And then minus 10 over the quintic root. And from indices, this is the same as 8x to the power negative 1 over 4 minus 10x to the power negative 1 over 5. Now when you differentiate dy dx, now the n has to come down. So negative 1 over 4 times 8x, negative 1 over 4 minus 1 minus. Now the negative 1 over 5 is coming down, so negative 1 over 5. We have times 10x, negative 1 over 5 minus 1. Now, 4 will go into solve 1, 4 will go into 8 2 times. 5 will go into 1, 5 will go into 10 2 times. So we have negative 2x. This can be 4 over 4. So that will be negative 5 over 4. Later, negative positive 2x. Negative 1 over 5 minus 1. That's negative 6 over 5. Negative 6 over 5. Wow, that is very easy, very, very trivial. At the edge, you call the numbers you are seeing on the screen for a copy of the pen drive. I've taken my time to explain everything. It's a wonderful material. All the lessons from Form 1 to Form 3, everything is available on a pen drive. I have the weak students in mind. Taking my time, I've arranged it according to the content of the syllabus, coupled with a lot of past questions and then a lot of challenging questions as well. Now let's consider this example. Differentiate the following and simplify your answer. Now let's note, you see, if you have, that is y to be equal to f of x all to the power n, then dy dx, dy dx. This is a chain rule, so n has to come down, n f prime, and then you differentiate the inner function, and then you reduce the whole function by 1. That is, we have y to be equal to fx to the power n. So dy dx is n, the n has to come down, differentiate the inner function, then reduce the whole function by 1. Hence, the first one, we have y to be equal to square root of 5x squared minus 4. And this is the same as we have our y to be equal to 5x squared minus 4 all to the power half. So dy dx, dy dx, dy dx. Now the n has to come down. Our n is half. So n has to come down. That's the n coming down. Differentiate the inner function. 5x squared minus 4 differentiate. What do you get? 10x. So differentiating this, we have 10x. Then reduce the whole thing by 1. Half minus 1. That's what we are using. Now, 2 going to self 1, 2 going to 10, how many times? 5 times. So we have 5x squared minus 4 to the power negative half. That's half minus 1. That's negative half. And this is the same as dy dx. This is the same as this. Because it's negative, it can come down. So we have 5x over square root of 5x squared minus 4. Wow, that's it. Very, very easy. Now let's see the second question. The second question, that's I. We have y to be equal to 1 plus 2x to the power 3, and then we have x plus 3. X plus 3. So that's what we have, and then we want to differentiate this. Now, this is a combination of the power rule and then the product rule. So the chain rule and then the product rule. Call the numbers and get a copy of my pen drive. I've taken my time, explain everything. Taking my time, solve a lot of examples, explain all concepts, everything. Call the numbers and get a copy for yourself. So here we apply the chain rule and then the product rule as well. So finding our dy dx. Now, let's differentiate this. Let's keep this constant. So when you differentiate this, the 3 has to come. Let's differentiate this. What do you have? 2. And then reduce the whole thing by 1 to the power 2. So 3 is coming down. Differentiate this. Differentiate the inner one. You have this and reduce it by 1. And we keep x plus 3 constant. So differentiate this, keep this constant. That is what we have. Plus, now let's differentiate this. When you differentiate this, what do you have? 1. Let's keep this one constant. 1 plus 2x to the power 3. Now 3 times 2, we have 6. Let's bring our x plus 3 here. 1 plus 2x to the power 2 plus, we have 1 plus 2x to the power 3. Now we can multiply this one and this giving us 6x plus 18. That's 6 times this, so that's what we have. 6x plus 18. We have 1 plus 2x to the power 2 plus 1 plus 2x to the power 3. So let's leave our answer and test 4. Now let's consider this example. I urge you to pause the video and try the question on your own. Now if y equal to square root of 3x plus 1, find I dy dx, and then the I find the second differential. Now let's see. We have y to be equal to square root of 3x plus 1. And clearly y is equal to 3x plus 1 to the power half. Now let's differentiate this. So dy dx, dy dx. Now what is the rule? The n has to come down. This n is half. So we have half coming down. Differentiate the inner one 3. Then reduce the whole thing by 1, which is 3x plus 1 half minus 1. And clearly we have 3 over 2, 3x plus 1, negative half minus 1, and this is giving us negative half. So this is our first differential, that's I, we need to find the second differential. So there are dy dx to be equal to 3 over 2, 3x plus 1, negative half. We need to find our second differential. So the square y over the x squared. So the n has to come down. The n has to come down. We have negative half. Differentiate the inner one. Reduce the whole thing by 1. Reduce it by 1. Now let's see. Negative 1 times 3, negative 3 times 3, negative 9. So we have negative 9 over 2 times 2, that's 4. 2 times 4, that's 4. And then we have 3x plus 1, negative half minus 1, and that's negative 3 over 2. Negative 3 over 2. So this is our second differential. I urge you to pause the video and try the questions on your own. No pain, no gain. Now let's consider this example. I urge you to pause the video and try the question on your own. Now if 6x squared minus 5y squared plus 3xy minus x plus 11, find dy dx at the point negative 1, 3. So we have 6x squared minus 5y squared plus 3xy minus x. This is equal to 11. Now we need to differentiate this. When you differentiate this, what do you have? We have 12x. When you differentiate 5y squared, that's 10y dy dx. But here we have to apply the product rule and the chain rule. So differentiating x will be 1. We keep the y constant. Plus we differentiate y. So x is constant, y that's dy dx. When you differentiate negative, yes, what do you have? Negative 1. Differentiating 11, what do you have? 0. Okay, so let's put together this and that. Let me bring the positive first. So we have 3x dy dx minus 10y dy dx, and this equal to negative 1 crossing, that's positive 1, positive 12 crossing, negative 12x, positive 3y crossing, that's negative 3y. Now what is the common dy dx, a common factor? Let's factorize it out. So we have 3x minus 10y dy dx. This is equal to 1 minus 12x minus 3. Why? We want to find dy dx. So clearly our dy dx will be equal to 1 minus 12x minus 3y. 1 minus 12x minus 3y divided by 3x minus 10y. Now, at the point, that is, when x is negative 1, y is 3. When x is negative 1, y is 3. So our dy dx will be equal to 1 minus 12. X is negative 1, y is positive 3. X is negative 1, y is 3. Y is 3. And clearly we have 1 plus 12, make that negative positive. Now minus 3 times 3, that's 9 over, now we have negative 3, 10 times 3, that's negative 30. 10 times, that's negative 30. Let's see, 12 minus 9, that's 3 plus 1, so 4. So we have 4 over negative 33. Negative 3 minus 30, that's negative 33, and this is equal to negative 4 over 33. That's 1 plus 12 plus 13. 13 minus 9. Yes, and that's 4. So that's negative 4 over 33. Now let's consider this example. This is Steve Cohn's ultimate revision guide. Are you afraid of mathematics? Are you struggling with mathematics? Meet the teacher who can make you love mathematics. I can break down difficult topics into something easier and understandable. Now, I have all lessons from Form 1 to Form 3. Everything is available on a pen drive for sale. I would urge you, call the numbers that you're seeing on the screen for a copy, and you will never regret. You would love mathematics because maths will be something that will be very exciting to you. Now, let's consider this example. Let f be a cubic polynomial. So very important. F is what? A cubic polynomial. Given that f of 0 is 2, f prime of 0 is negative 3, and then f of 1 is f prime of 1, and f prime of negative 1 is equal to 6. Find f of x. Now, f of x is, that's ax cubed plus bx squared plus cx plus d. Why? We are being told that f of x is a cubic polynomial, and since it's a cubic polynomial, it will be of this form. Now we are being given that f of 0 is 2, so they've given us that f of 0 is 2. Now, what is f of 0? Now, wherever we see x, we put 0 over there. You see f of x, in place of the x, we have 0 here. So wherever we see x, we put 0 over there. So we have ax, that's 0 to the power 3. B, what is x? 0 to the power 2. C, what do you have? 0 plus d, and this is equal to 2. Now, this will be times 0, 0, 0. So we have d to be equal to 2. Wow, d is equal to 2. Now, we've also been given that f prime of 0 is equal to negative 3. So we are given that f prime of 0 equal to negative 3. Now, let's find f prime of x. Now, we know that our f prime of x, when you differentiate this, what are we getting? When we differentiate this, we are getting 3ax squared y squared because 3 minus 1 plus 2bx, because 2 come here, 2 minus 1, that's 1, and then plus c. When you differentiate this, you see 1 will come here, 1 minus 1, 0, x to the power 0 is 1. So when you differentiate this is what you can get. And this is a constant. When you differentiate the constant, you get 0. Now f prime of 0 is negative 3. Now we have our f prime of 0. Let's find our f prime of 0. Wherever we see x, we put 0 there. 0 plus c. But f prime of 0 is negative. In place here we have negative 3. But this is 0, 0. So c. We have our c because this will be 0. This will be 0. We have our c. So c is equal to negative 3. So c is equal to negative 3. C is equal to negative 3. Now, we have also been given that f of 1 equal to f prime of 1. We've been given that f of 1 to be equal to f prime of 1. Now, f of 1. What is f of 1? Here, wherever we see x, we put 1 over here. So putting 1 here, we have a 1 to the power 3 plus b 1 to the power 2 plus c, we have 1 plus d equal to f prime of 1. Now, where is f prime of x? This is f prime of x. So in place of the f prime of x, we have 3a x squared, so 1 to the power 2 plus 2b, we have 1 plus c, Now, okay, so a times 1, so that will be a plus b plus c plus d, because 1 times b, 1 times a, 1 times c is going to do the same thing, and this is also, we have 3a plus 2b plus c. Okay, now we know that our d is 2, our d is 2, and then our c is negative 3. So d is 2, c is negative 3. So let's see, a plus b, our c is negative 3. So we need to change this one to, and then what is our d? Our d is 2. Our d is 2. And this is equal to, we have 3a plus 2b. Our c is negative 3. Now, let's bring this one over and let's take this to the side. Negative 3 plus 2. Negative 3 coming, that's positive. And this is equal to 3a. A is going negative a, 2b. This moving minus b. So this and this moving here, this one coming here, and this will cancel this. So we have 3a minus a, that's 2a, 2b minus b, that's b. So we have 2a plus b equal to 2. Let's call this equation 1. Now, let's see, we have also been given that f prime prime of negative 1 to be equal to 6. Now, we know our f prime of x. What is our f prime of x? Our f prime of x is 3ax squared plus 2bx plus c. But what is the c? C is negative 3. Now, let's find the second differential. When you differentiate second differential, this 6ax plus 2b. And when you differentiate a constant, we get 0. Now, f prime prime of negative 1 is 6. I've been given that f prime prime of negative 1, this is 6. So wherever I see x, I'll put negative 1 here. So I have 6a negative 1 plus 2b, and this is 6. Now I can divide through by 2. So when divided by 2, here I'll be getting negative 3a divided by 2. I'll get b divided by 2, and this is 3. And this is our equation 2. So we solve equation 1 and equation 2 simultaneously. Now, so what can we see? We can see that equation 2 minus equation 1. We are using elimination method. So clearly, now, negative 3a minus 2a, and this is negative 5a. Now, b minus b, that's 0. 3 minus 2, and we have 1. So clearly, our a is negative 1 over 5. Negative 1 over 5. So we can put a to be equal to negative 1 over 5 into equation 1 for the b. And clearly, what do you have here? We have 2a. But what is our a? Negative 1 over 5 plus b, and this is equal to 2. So we have negative 2 over 5 plus b equal to 2. What's the LCM? LCM is 5, so this times 5, this times 5, this times 5. So that will be negative 2 plus 5b equal to 10. 5b will be equal to 12. This moving there. b is 12 over 5. b is 12 over 5. Hence, we are being told to find our f of x. Now, our f of x is a x cubed plus bx squared plus cx plus d. Our a is negative 1 over 5. So you have negative 1 over 5x to the power 3. And what is B? Our B is 12 over 5 x squared. What is our C? Our C is negative 3. C is negative 3. So in place of the C, that's negative 3 x, negative 3x, negative 3x. What is our D? We had our D, 2, B, 2. So this is our f of x. Don't forget, no pain, no gain. Mathematics is not a spectator of sport. Meet the teacher who can break down difficult topics into something easier and understandable. I have wonderful lessons on pen drive for sale. Call the numbers for a copy for yourself. All the topics, any of the topics that you think they are challenging, everything is available on the pen drive. For sale, probability, we have mechanics, we have vectors, permutation and combination, binomial theorem, everything, all the topics, trigonometry, everything is available on a pen drive. So this is just a revision guide. What you are seeing on YouTube is just a revision guide. All the ones which are for sale are on pen drive, and when you call the numbers, you'll be able to get a copy for yourself.